Hello everyone, and welcome to Lesson 3. In this lesson, we'll cover 3 topics. First, what a Boolean expression is. Second, a simple method for drawing the schematic from an expression. And third, we'll work through examples step by step. Alright, let's get started. So, what is a Boolean expression? Well, a Boolean expression is simply a compact way to represent a digital circuit. Instead of drawing the entire schematic right away, we can write one equation that describes exactly what the circuit will look like. Every time you solve a truth table and obtain a Boolean expression, the next step is to draw the logic gate schematic that implements that expression. That's what we'll practice in this lesson. In a Boolean expression, there are 2 main things you want to look for. First, look for variables that are grouped together with no plus sign between them. When variables are grouped together like that, it means they are fed into an AND gate together. Second, look for the plus signs. A plus sign separates groups, and that means those groups are fed into an OR gate together. So, here's the method. For each group of variables, draw a single AND gate that takes all of those variables as inputs. Then, take the outputs of all of those AND gates and combine them into one OR gate to produce the final output. And finally, remember that if you see a tilde, a tick mark, or a bar over a variable, that just means the variable is inverted before it goes into the gate. So how does this example work? Well, if we look at the expression, there are 3 terms separated by plus signs. The first term is a prime b prime, so we draw a 2-input AND gate using a prime and b prime. The second term is EFG, so we draw a 3-input AND gate using EF and G. And the third term is just V by itself, so that term doesn't need an AND gate. It is already a single signal. Next, we take the output of each term and feed all of them into a single OR gate. That OR gate produces the final output Y. So how does this example work? Well, if we look at the expression, there are 2 terms separated by a plus sign. The first term is a prime B, so we draw a 2-input AND gate using a prime and B. The second term is a prime B prime C, so we draw a 3-input AND gate using a prime, B prime, and C. Next, we take the output of both of those terms and feed them into a single OR gate. That OR gate produces the final output G. So how does this example work? Well, if we look at the expression, every term is separated by a plus sign. That means this is just an OR of 3 single variables. The terms are a prime, B, and C. Since none of these terms are grouped together, we don't need any AND gates. We simply feed them all into a 3-input OR gate. The output of that OR gate is Z. Alright, now it's your turn. Go ahead and pause the video and try to draw the schematic for this Boolean expression on your own. Using the rules, you should have gotten this schematic right here. Alright, let's have you try one more. Go ahead and pause the video and try to draw the schematic for this Boolean expression on your own. Well, using the rules, you should have gotten this schematic right here. Alright, so that's pretty much everything you need to know for Boolean expressions. At this point, anytime you solve a truth table and obtain a Boolean expression, you should feel confident in drawing the schematic that implements it. In the next lessons, we'll build on this and start using these ideas to design larger and more interesting digital circuits. Alright, I'll see you in the next lesson.